Okay, so it's 11 a.m. and I guess we can start another presentation. Hello everyone, my name is Przemek, and today I'd like to talk about so-called web components. So first, I'd like to ask you to forget about your daily jobs, about things you do at universities, about your daily responsibilities. And I'd like to ask you to imagine that you've just joined this kind of garage-based startup called Smart Company. And so there are 5 people in total, and you are the only one who is responsible for the front-end layer of this company. So you have huge autonomy. And my pilot is not working, but no worries. Okay, so you have huge autonomy, right? 5 people, you are the only front-end developer. So you are going to a grocery store to pick the framework the solutions built by this company will be based on. So you are considered as an Angular expert, you know Angular, you can build stuff based on Angular. So of course you pick Angular. So everything which will be developed in this company will be based on Angular. And everything works really well. So the pace of development is really fast, you are able to develop features very quickly, your chiefs and managers are happy because of the progress you are making. But after a few months, you noticed a small problem. The problem is related to the fact that everything in your life is going around the Angular prefix. So when your mom calls you, her name starts as an Angular dash. And the same with every single contact on your contact list. When it comes to your friends, the names of your friends also changed. So your dog is now called Angular Doggo. And he's super happy because of this, right? When it comes to software development, when you're looking for components, when you're searching through registries like NPM, you are doing the same thing. So you're going to NPM, for example, you type Angular dash because you are only interested in things from Angular ecosystem, let's say, and you scroll and browse through the list of components. So what's the problem here? The problem is that you landed in this kind of Angular silo. So you are limited to Angular. You are limited to ideas around Angular. You are limited to authors writing about Angular, speakers talking about Angular. And maybe you'd like to play with other frameworks, you'd like to experiment. But you can't, right? Because social media tells you that you shouldn't do this, right? You shouldn't mix frameworks. Either one thing or another thing, right? You picked Angular, so please do not touch React. And it would be very nice to end up here, this story, and summarize everything that, it's a fairy tale about dragons and magic and, it's artificial, but something like this happened in the company where I'm working at a few weeks ago. So a member of Smart Recruiters shared this set of accessible components on our front-end channel, but she was not aware that our stack is based on Angular. So front-end team took some time to review everything, and unfortunately we had to respond that this set of components is, it's really good, it's really important, and it's written very well, but it's based on React. So we cannot reuse it, right? So we are in Angular silo, we are locked by a vendor, by a Google, and that's all, that's our case. And the Smart Company had the same problem. But their problems were even worse, because they grew. They grew a lot. So the customers were very happy because of the stuff they were selling. They moved to the cities downtown, to these big offices in skyscrapers. And they said, we want to fight with this problem of technology silos. So they set up different engineering departments. And in every engineering department, you can pick any technology you want, because they value openness. But yet another problem occurred. For example, when one of the teams is releasing component, and they are writing on their Slack something like, introducing avatar component, right? We've spent 1 week building avatar. Now we are announcing it globally. So guys who are using different frameworks, they are asking them, can we reuse it? Because we need exactly that. And the response is, it's complicated, right? You are using Angular, we are not using Angular. Maybe not this time, right? So smart company created an environment where openness for different kind of technologies is valued very strongly, but actually there are these hidden connections between teams. So teams using the same framework can talk to each other, and if you're using different framework than I am using, right, we have nothing in common. We can't talk to each other. So once again, they noticed this problem, and they set up this special ops team, this kind of Navy SEALs of the front end, and they said that, guys, you are the best, and you should solve it somehow. And they took some time. It took some time for them, and after months of research, they announced that they have a solution. And this solution is this mysterious thing called Web Components. My name is Przemek Smyrdek. I work at Smart Recruiters, a software company. We are developing software, we are not hiring agencies, something like this. And today I'd like to answer this question about web components. Where are we? Are we there yet? Are web components ready for 2018? And we can start from a demo. But wait a second, okay? There will be a demo, but it will be in the second part of this talk. But first, let's try to focus on the more theoretical parts of the web component specification. So first, you may ask what this thing is all about, right? Is this like a one technology, one spec, or this is a set of specs? So actually, no one knows, right? When you are reading different blog posts, different articles, when you are watching videos on YouTube, there are different answers for this. So for some people, there are 3 main technologies inside of web components. For others, there are 4 elements. For others, there are 2 specs, right? So 2 and 3 and 4 at the same time. It's not so easy to tell. But we can do something different. Instead of trying to answer this question about sets which are included in web component specification, we can ask a different question. Question like this: what are the limitations of modern web? Why this kind of question? Because we can assume that any kind of new invention, any kind of new thing which will be pretty and fancy and work well, will need to solve the problems of this kind, right? This tool will need we'll solve these limitations of modern web at some time. So what are those limitations? So first limitation I'd like to talk about is the limitation of language. So as you know, in English language, for example, there is a finite set of words. As a speaker, I cannot say something like, blah, 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 because you won't understand me, right? Besides this, I hope you understand me. So that's the case, right? So the number of words is fixed. And yet, knowing the fact that the number of words is fixed, we are always trying to find the best words to describe things, facts, objects, animals, and so on. If we are doing something like this, it means that we care about semantics. And what is semantics? As this famous person for every single front-end developer, Nicholas Gallagher, once said, semantics are largely concerned with the aggregate meaning of HTML elements. So basically, if you care about semantics, you would like to find the best words to describe something, to describe fact or object or a meaning, something like this. And as a front-end developers, we are doing this all the time because we are building websites, and the structure of our websites consists of this kind of words. And words for us means HTML tags. And the same as in English language or in any other languages, the number of tags is limited, right? That's why we are using frameworks like Angular or React or even jQuery widgets to be able to enrich our language, to be able to find a bigger number of words we can use, and basically to express ourselves better, to be understood, easily without any problems. So when it comes to web development, from time to time, something new happens, like HTML5. HTML5 introduced a new set of tags, new set of words we can use to express ourselves better. So before HTML5, we had to write something like divs with classes, and now we have tags like videos, articles, and footers. But the problem is that this pace of changes, these periods where new tags happens, is First, it's very slow and the periods are very long. So it's not that often to see new tags like in HTML5. And it's very slow, and it reminds me, using RapidShare as a free user. So it's really slow. Okay, so we know that the limited number of words is a limitation for us. And that's why there is this first part of Web Components Specification, and it is called custom elements. So custom elements, it's about teaching browsers new words. So we are no longer connected to the specifications, to the official standards. We can build things which we'd like to. And this is how it looks like. So on the top, there is a usage of this kind of custom element in HTML5. We have something like custom avatar, and you can see that there is a dash. And that's the difference between standard tags, because in standard tags, there are no dashes, basically. So if there is a dash, you may assume that it will work as a custom element. That's not a rule, but that's more or less true. When it comes to implementation of this kind of custom element, you need to start with a regular class, and this class has to extend something like HTML element or other classes which derives from it, like HTML paragraph element, HTML span element, and so on. Inside of this class, just like with frameworks you are used to, there are lifecycle callbacks. So there are functions which will be called at different points of life of this custom element. Like connected callback when this custom element will be added to the page, disconnected when it's going to be removed, adopted when the document will change, and also the last one is very important because you can subscribe for changes of the attribute values, attributes and properties. And the last part of this custom element registration is about like adding new element to the registry. There is this registry called custom elements. It's global in every single browser which supports the standard. And you can call a method called define, where you pass a name of custom element and let's say a specification of it. So what can you do inside of such elements? So you work with custom elements just like with any other regular nodes in the DOM. So for example, you can read and write values of attributes. You can set values of properties like inner HTML, for example, to prepare a template of this custom element. And you can use some methods in a very imperative manner, so you can create elements, create child nodes, and so on. So the same applies to the other regular DOM elements like divs, spans, so it's the same thing. When it comes to data flow, it's also similar to the thing you are doing, for example, when using React or Angular. So when you want to pass the data from top to bottom, you are doing this by passing them through attributes and properties. So the same like, for example, props in React. When you want to notify parent components about things, you dispatch events. So the pattern is very common, and most of us, the front-end developers, should be already used to it because we are doing it in other frameworks. So that's the pattern. And another thing about custom elements is that they are versioned, and currently there are 3 versions. So on the beginning, 2011, there was something called V0, and it was a spec, like utopian idea created by Google. So Google created this idea of custom elements, and they said, we're going to implement it in Chrome. Other browser vendors started to complain. There was tons of arguments, and it failed. So it's now deprecated. A few years later, a working group has been created, and their members working in companies like Apple, Microsoft, Google, and Mozilla. So they are like representatives of major browsers, and they've managed to establish a standard, which today we know as a custom elements v1, and it is official standard implemented in most of the browsers as of today. And there will be version v2 with, let's say, improvements on top of this official standard. So that's the basic idea of custom element. We'll talk about this more a bit later. And another limitation I'd like to talk about is about global. So global as a word is not bad because, for example, we live in a global society, right? You can book a plane, you can jump into it. Few hours later, you are, for example, in the United States. You can buy alcohol, which is not available in your country. So living in a global society is not that bad. But when it comes to web development, global means troubles. So let's take a look at this very basic example of HTML and CSS. So on the top, we have a set of rules, a set of CSS rules, which we'd like to apply to an element with class box. So we'd like to create box with white background, with 10 pixels padding, and with this kind of border. Unfortunately, our colleague adds another library which we consider as an external, and this library is also touching the same as elements with the same class. So as a result, our box is no longer white, it's red. This is because every single time, if you know the selectors, you can style different parts of your website using CSS. That's how CSS works. Is it good? It's not good. So that's why yet another standard happened. And this time the standard is called Shadow DOM. And the important fact about Shadow DOM is that it's not like a completely new thing. It's already in our browsers, but when it comes to Shadow DOM in the context of web components, it's about opening this to regular developers. So you don't need to work in Google or Microsoft or these browser vendors to use Shadow DOM. When web components will happen, everyone can use Shadow DOM. That's the main difference. So let's take a look at slightly modified example from before. So there is the same box, there is the same styling, and there is something like a custom box expressed as a custom element. So you see that the second box has the same rules applied to it, but somehow the first one works fine. It works as we would love to see it. So how does it work? To explain you how does it work, first we need to think for a while about how the browser loads our pages. So when we write, for example, HTML, which is declarative structure of our page, browser converts it to something like a DOM. DOM is an object representation of various nodes and node properties, and as a result, you have something like a tree which represents your website. So it's a tree of objects. So Shadow DOM is all about creating this kind of shadow nodes and shadow trees, which will be hidden from the external world. So everything which happens inside of the shadow tree will stay unmodified, exception, but that's for another topic. But in general, it will stay unmodified unless you want to do something with it. And at the end, it's very important to say that when the browser renders everything, a new tree is being created, and it's called a flattened tree. And as a result of this flattened tree, you can, for example, debug this shadow trees and shadow elements. I will show you it in a while. So that's how it works. You have the same custom element as before. So there's a class which extends HTML element, and you are using this new method called attachShadow. So attachShadow returns a reference to the shadow node. So this will be a first node in the shadow tree, and inside of it you can do whatever you want. So for example, you can update templates, you can create styles, and so on. And the very important fact about this approach is that these styles will be local. So they are no longer global, like in CSS. And as you see, there is also this thing called mode. And mode is about having an access to the shadow node from outside of custom element. So if the shadow tree is open, you can modify it from the external world. You can, for example, get a reference to it once again. If it's closed, it's read-only, let's say. So that's the basics. When you debug it, as I said earlier, you can check the flattened tree. So the tree which consists of regular trees, regular set of nodes, and nodes marked, which live in a shadow, let's say. So that's because of this. That's because of the structure. And yet another important fact about this is that in modern browsers, you can enable something like a user agent Shadow DOM, which will show you how browser vendors express already existing elements. So without this flag, in the structure of your page, you see only something like video, right? You cannot expose its internals. When this flag is marked, you see what's going on inside of regular video. And the same applies to, for example, select and many other more complicated elements. And it's possible to toggle this element in developer tools of Chrome, for example. But yes, more problems. When you look at something like this, there is this red dot blinking in your head, right? So there is a template expressed as a string. It's inside of JavaScript. Yeah, maybe we could separate the concerns somehow, right? Maybe we could delegate the template to some other parts. And that's why there is third part of Web Components Specification, which is called templates and slots, to be more precise. So templates give you this possibility to create dynamic components and make it extensible, let's say. When we look at the regular web components, we can have different kind of problems when writing them. So for example, one can write the same template inside of two different components. Because, for example, they are developed by two people, they know nothing about each other, so they think that I'm doing this for the first time, right? So there's a problem of duplicated code. So another problem is the thing I was mentioning before, and it's about writing templates inside of regular string templates. So what can we do about it? We can use something like a template. And template is a HTML tag which is hidden from the rendering process until you want it to be displayed. So in all of the browsers we are using today, even in Internet Explorer 11, you can create this template tag and its internals won't be rendered. So there is a before template content header, it's after template content header, and inside there is nothing. So when you mix Shadow DOM and templates, things get more interesting. Why? First, there will be a template, and this template won't be rendered, so it's good. And from the JavaScript code, from the code where we define our custom elements, we can get a reference to this template, and we can just append it as a child to our newly created element. And it works really well. And there are a few pros, like the styles. Styles are local, so it's working in the same way. You are using HTML to create templates, and you can reuse the same template in multiple custom elements at the same time. When it comes to extensibility, there is additional feature called slots. And slots is about creating this kind of placeholders with defined names, like extras, which can be filled by custom element consumers. So this template, let's say it's a part of something like a custom hello worlder, and there is placeholder, you can put something inside of it. So for example, you can put a paragraph or more like a rich elements, and it will work like this. So three main elements: custom elements to enrich our language, Shadow DOM to create encapsulated styles, encapsulated elements, and templates and slots to make our components dynamic and more extensible. But when you think about people using custom elements and web components, that's the number of consumers, right? You may think it doesn't feel like a React, it doesn't feel like Angular. So what the hell is going on, right? Is anyone using this thing? It's a valid question. I was thinking about the same. And there are a few more questions we need to try to find an answer for. So first question is about browser support, right? You may sit there listening about web components and thinking that, okay, there are no browsers which supports this technology. Others may think that, yeah, this specification is using DOM, and we know from our parents, which were writing their apps in jQuery, that DOM is terrible, right? So we shouldn't do this, DOM is slow, and it's not gonna happen. And the third thing is about performance. So during every single talk about JavaScript frameworks, there has to be something about performance, and I'm going to do the same thing here. But let's start from the browser support. So why is that when you are reading different blogs, different articles, different publications, why is that there is nothing like a single definition of web components? Well, because of Google. So in 2011, there was this talk by Alex Russell on the Frontiers conference when Google presented the specification of web components, and they didn't ask anyone about internals. So they presented the specification. They said it's our standard. We would like to have it in every single browser. And as you can guess, other vendors were not happy because of that, right? They felt like someone forgot about them. So the history of web components is one very interesting soap opera where 4 browser vendors are constantly arguing about details. So everything started in 2011, and 2017, 18, and onwards, it's going to be pretty similar. It's a bit better nowadays, but the issues from the beginning are still there. So when you are reading blogs, you can see tons of complaining, right? So there is something like a very popular post called "The Broken Promise of Web Components." So Google, you were promising that it will solve our problems. We are not going to use Angular or React anymore. Everything will be native. You broke the promise. For example, there are multiple issues on GitHub about also complaining, where people are complaining about internals, asking questions. Those questions are unanswered. So it's a bit crazy. After spending like 2 days, if you want to spend 2 days reading about it, you may feel that it's crazy, right? It's not gonna happen. But the reality is a bit better. On the left-hand side, there are 2 browsers we can omit for a while, like Internet Explorer and Edge. Let's forget about them for a while. And Firefox. So starting from 28th of October, so it's like in 13 days, in Firefox version 63, custom elements will be open for everyone. Chrome supports it since they invented this idea. Safari, without small exceptions, also supports everything I shown you here. The same with Safari on iOS and major mobile browser vendors. And the spec is the custom elements v1. The same with Shadow DOM. So the same table, the same support rules. Also, no Internet Explorer support, unfortunately, no Edge support, but the rest is the same. What about Edge? So in 2015, they promised that they're gonna implement web components. We were waiting 3 years, and 7 days ago, they changed the status of the spec from under consideration to in development. Woo! So yes, there are people who are happy because of this, right? We were waiting for 3 years. Someone in Microsoft checked the page. Shit, we promised something. Let's try to ship this. So yeah, web components will be available in Edge probably next year. When it comes to third part, HTML templates, it's better because Edge supports it already, so it's not that bad. Of course, there are polyfills. There are replacements for the native functionalities you can use. And they are available on this web components repository, which you can check by, for example, downloading the stock. I will share the slides later. Yeah, so the second question, what about the DOM? Is the DOM okay, right? There is this package React DOM. And it was developed by a company called Facebook, and this company also created this framework called React. And as you know, React is not in love with DOM, right? They are working on their own abstractions. They have abstractions for events called synthetic events, so they want to live in a separation from the DOM. But even Facebook, if they want to be rendered in a browser, they have to create something like React DOM. They have to create this bridge to use DOM at the end, because every single browser uses the DOM, and knowing that fact, we can say that there is this common bridge between every single framework, this DOM, because at the end you have to use it. If you want to do this, if you don't want to do this, you have to use DOM, because you want to render things in the browsers, right? At some point in the future there may be changes, but for now you have to use the DOM. But for sure there are people who are saying, yeah, forget about it once again, because I don't like DOM. Wait a minute, there is something special for you. So as you know, in terms of web development, there are two kinds of areas where we develop features. So there is area which is user-friendly with languages like TypeScript, Dart, and any other abstractions, and it compiles to something which is browser-friendly, so JavaScript. And the same pattern can be applied to web components. So there is this user-friendly area, and there is browser-friendly area. If you don't like the specification in the browser-friendly area, you can create some kind of higher-level abstractions, which will be compiled to browser-friendly, let's say, specs. And exactly this thing is happening, for example, with TypeScript, with Dart, with ReasonML. So those languages have their own compilers, and they compile to JavaScript. And the same pattern relates to web components. So there are more high-level wrappers, which helps you avoid talking directly to DOM. They enables you using APIs you are familiar with, like for example Angular elements, where you are creating components as they would be written in Angular, and later they are being compiled to web components, and it works. It works fine. It's still it's in very early stages, but it works. So that's the general idea. If you want to use this kind of higher level APIs today, there are a few solutions. So for example, there is Stencil, developed by a team responsible for Ionic. There are frameworks like Skate.js, there are ideas like Angular elements, there are wrappers for Vue, there is this framework developed by Google called Polymer. So this is all about creating user-friendly solutions which are being compiled to browser-friendly standards. One of the most mature here is probably Stencil. Stencil is a so-called compiler which produces web components, and when you're using Stencil, you can use very similar patterns as you would write, for example, apps using React. So there's virtual DOM, there's async rendering, data binding is better, much easier. You can develop things using TypeScript and JSX. So that's it. And because of this pattern, the more and more publications is published in this context. The context is that if you are a front-end developer and if you want to write important things, maybe you shouldn't be focused on frameworks anymore. Maybe you should be focused on compilers and compiler internals. Because if you know how to compile this user-friendly thing to browser-friendly thing, basically your solutions will work always, no matter what. So compilers are the new frameworks. And the last thing I'd like to talk about is about performance. So web components are not touching the topic of performance directly, so your apps are not running faster because of web components, but there is this interesting fact about using them. So currently, when you want to let users of your application basically play with them, they need to do two things. First, they need to install a set of browser APIs. So there's an installation phase. And the users of your application are doing this while installing a browser on their operating system. So they need to install browser APIs. Then you, as an application developer, you are providing application itself and the runtime. So for example, minified Angular, minified React, and so on and so forth. So there's a fetch phase. So with web components, it can become like this. So there will be more browser APIs supported natively, and there will be no need to fetch them. So the expectation is that apps will be smaller at some point in the future, because there will be more native features like batteries included. They will be based on C++, they will be considered as a native. And yeah, that's very promising. I think that's very promising. And actually, you can check how does it look like in Polymer Framework. So with every single release of Polymer Framework, and with more mature platforms, let's say, the total size of this framework is much smaller. So when they developed Polymer at the beginning, it was of 53 kilobytes of size. So the platform got more mature, there was more native features included, and now Polymer in Chrome is only about 10 kilobytes, because there are more native features included. So we can say the more mature the platform becomes, the less code you need to ship, right? Batteries inside. So when you take a closer look at the internet, at the different case studies, you can actually see that there are people who are using web components today. So few months ago, GitHub moved to native. They removed jQuery from their code base, and some elements are now based on web components. And there is this blog post where they described everything. Last year, YouTube rolled out a new version of YouTube, and this one based on material design, and YouTube is fully built fully with Polymer. And for example, Ionic, this, let's say, framework, a solution dedicated to building cross-platform applications, is also betting on Stencil right now. So at the beginning, they were using Angular, but they don't want to participate in this, rat race, which framework is better, so they decided to use something which will be closer to the native solutions. If you want to check how the frameworks you are using today, how they cooperate with custom elements, there is this page, custom elements everywhere, and it's about making sure that frameworks and custom elements can be best friends forever, right? So frameworks like Angular supports interoperability with custom elements for 100%, the same with AngularJS, Vue, Dojo. The framework which supports it in the worst way is, guess what, React. So there are issues when it comes to interoperability, but they are related, they are caused by the fact that React lives in this kind of separation. So there is React and there is the rest of the web, we can say. So for the end of this presentation, we can go back to this example of smart company. And this topic of cooperation between teams using different frameworks. So I show you that they set up this Navy SEALs team, which was responsible for finding a solution, finding this bridge between custom elements. And now I'd like to show you how it works. So there will be a quick demo. Let me find the cursor. It's there. Okay. So, Smart Company decided to build their design system using web components. They created 3 basic elements because they want to convince boss that this is a technology they would like to invest more money into it. So they just created something like a smart clock. They created something like a smart greetings and smart avatar. So depends on the component. There are different levels of modifications of extensibility. And I will show you how it works in different departments of this company. So first, they asked guys from React department if they can integrate those components with React. And actually, it works really well. So there is not much customization about it, but you can put custom elements inside of React apps. It works well. So clock is ticking, I hope so. Yes, clock is ticking. This greeting is working, and avatar is also here. So then we can see how it works in the Vue department. So I show you that Vue supports it. I told you that Vue supports it for 100%. So we can check that, for example, different events are working well. You can open, close things, right? You can click on the buttons, like front end, right? So everything works well. When it comes to integration with Angular, they went even more forward, and they decided to build a whole application based on custom elements and web components. So in Angular, they created this kind of contact list with the same components. So there is a greeting, there is a clock, and there are avatars. And the binding between Angular and custom elements works well. You can open different, let's say, sections here. So you can call your contacts and so on. So that's the pattern. That's the pattern that will be probably the most popular at some point in the future. So this kind of core teams, core front-end teams in companies will probably create their reusable elements using web components so that teams using other frameworks can reuse them in their apps. So that's the demo. And few slides to the end. Oh, okay. Yeah. So that was the demo. So what's the answer for this question? What's the answer for this question from the beginning? Are we there yet? We are closer than ever before. Web components are supported by most of the major browsers. Edge will support it next year, so we are very close. this time for real, just poke Edge developers to work faster and deliver, more features sooner. There are resources at the end of this talk. You can read different things and facts and issues and problems about web components. And there is this demo on my GitHub, and that's all. So thank you for your attention. Okej, nie wiem, czy mam jakieś pytania. Po polsku też możemy, czy nie? Nie mamy pytań. Okej. Tak, tylko właśnie w Reakcie sytuacja wygląda tak, że React ma swój własny system eventów, który jest niezależny od domu. Oni to nazywają synthetic events i można tego używać, ale powiedzmy w oparciu o haki. Czyli na przykład nie pracujesz ze zwykłym komponentem tak jak w Reakcie, tylko musisz pobrać najpierw referencję do natywnego node'a w domie. Nie pamiętam, jak to w Reakcie się nazywa, jak z Angularem pracuję, ale jak masz już tą referencję, to możesz na tym dispatchować eventy, możesz subskrybować i tak dalej, i tak dalej. Także jest to możliwe z kilkoma wyjątkami. Właśnie React nie jest za bardzo tym zainteresowany. Nie jest tym zainteresowany. Oni się wypowiadają na różnych grupach mailingowych, że web komponenty idą w całkiem inną stronę. React jest zainteresowany bardziej jakby deklaratywnym podejściem. Oni czekają na kilka zmian, które sprawią, że to będzie przypominać Reacta. Na przykład Shadow DOM, który teraz się robi tworzy się poprzez metodę attach shadow. Oni chcieliby, żeby to był na przykład atrybut na elemencie, czyli bardziej deklaratywny sposób, tak jak w Reactie. No ale taki pomysł został jakiś czas temu zatrzymany, także tak to wygląda. W pozostałych frameworkach jest OK, React jest na razie z boku. Tak. To znaczy, jak chodzi o ten najbardziej surową wersję, to jest słabo, ale to jest słabo dlatego, że coś takiego, co jest natywne w przeglądarce, to nie może być abstrakcją, no nie? Abstrakcję na tym będziesz dopiero budował, tak naprawdę. Takie frameworki powiedzmy narzędzia jak Stencil będą ci ułatwiać tą pracę z web komponentami, będą ci robić to przyjazne API, ale przez to, że to jest natywne, to musi być jakby surowe, no nie? Bo ty możesz sobie tam wymieniać klocki. To jest to, czego na przykład frameworki ci teraz nie dają, bo dużo funkcjonalności jest zamkniętych, no nie? Także tak, szczerze nie jest to super przyjemne, trzeba kombinować. Ale idea jest taka, jak pokazałem. Okay. Chyba nie mamy więcej pytań, także dzięki za uwagę.